Welcome to new measuring system of angles. Angles in radian measure. How to convert radian measure to degree measure and back. Commonly used measuring unit for angles is degree measure. And the basic unit is 1 degree. 1 degree is a very small angle. We are going to have another measuring system for angles now. It is based on a circle. The definition is based on a circle. That is why the system is called circular system. And 1 radian is the basic unit. What is 1 radian? How is it defined? Let's see. Definition goes this way. The measure of the angle subtended at the center of a circle by an arc of length equal to its radius is called 1 radian. What does it mean? The measure of the angle subtended at the center of a circle by an arc of length equal to its radius. Let's take an arc on this circle whose length is equal to radius. Yes, this is an arc whose length is equal to the radius of this circle. Now, let this arc subtend an angle at the center. Here it is. And this is called 1 radian. 1 radian is quite a big angle in comparison with 1 degree. 1 degree is very small. 1 radian. This is 1 radian. Now, let us see, does it depend on the size of the circle that we have taken? Let us check. I am going to take a smaller circle. The radius is smaller. So, the arc length that I should take also will be smaller. This much radius only should be the length of the arc. So, the arc goes this way. Here it is. And look, that new arc on the new circle subtends the same amount of angle at the center. I have taken two concentric circles. The center is the same. Just to compare. Now the angle subtended at the center is the same. Let's check by another circle. Still smaller one. Radius is still smaller. So the length of the arc will also be obviously smaller. Now this small arc subtends the same angle at the center. Hence, we conclude that this definition is irrespective of the circle that you are taking. Whichever is the circle, the measure of the angle subtended at the center of a circle, any circle, by an arc of length equal to the radius of that circle is called 1 radian. Now, why do we need this new measuring system now? Isn't it comfortable to go by the degree measure itself? Maybe comfortable, but the trigonometric functions that we defined recently are defined in terms of angles measured in radian measure. So we need to know the measure of angles in radian measure, that is in circular system. Let's learn little more about this new measure. Here, I've already taken 1 radian here measured in this circle. Now, let's go ahead. Take one more arc whose length is same as the radius length. Now subtend it. Subtend an angle at the center. You get another 1 radian. This also is 1 radian. Equal angles, of course. Then go for another arc. Subtend another 1 radian. Go for another arc of length equal to the radius. You get 1 more radian, etc. Now let's see. By the time we complete the one full rotation, one revolution, how many of them we will be able to get? We got 4 so far. 4 big angles. 1 radian is quite big. How many might be there? Let's go ahead. 5th one coming up now. Yes. 6th one is here. Here it is. But you notice the remaining portion is not fit for one more radian. There is little balance, which is this arc is less than the length of the arc that we had been taking. So the angle subtended at the center will not be equal to 1 radian. That's going to be less than 1 radian. How much is it? Exactly how much? We need to check. See, 1, 2, 3, 4, 5, 6 radians we got complete. But how many radians are possible in one revolution? Little more than 6. And the 7th radian, since it is not complete, the actual number of radians will be less than 7. So the amount of radians in one full rotation will be something between 6 and 7. How much is it exactly? We need to know. We'll go further, investigating it. Look, circumference of the circle is what we had been cutting into pieces. Circumference is from this point to all around complete circumference. This we kept cutting into pieces. How many pieces? That's what we want to know. As many pieces of r, that many radians are possible. So, this circumference which we can obtain by the formula 2 pi r, where r is the radius of the circle and pi is the constant approximately equal to 3.14. This is the total circumference. Let's divide the circumference into r to get how many radians will be possible. Radian measure in one revolution will be 2 pi r upon r. How many r's could be divided? Divide and see, we get 2 pi. 2 pi radians. What is this 2 pi radians? 2 pi radians. Just now we mentioned already, pi is approximately equal to 3.14. That is a constant. So 2 pi will be 2 into 3.14. That is 6.28. So this is that exact number. Between 6 and 7 we already found. So that is exactly speaking 6.28 radians. So we have 1, 2, 3, 4, 5, 6 full radians and 0.28 radians more to complete the rotation. So in one full revolution, the angle covered in radians is 2 pi radians, or in other words 6.28 radians. Now let's recollect. The total angle from here to here in one full revolution, if we had done it in degree measure, that would have been 360 degrees. That we are very much familiar with. So this one full rotation, 360 degree and 2 pi radian, they both must be same. So we can say 360 degrees must be equivalent to 2 pi radians. This is the relation that we have between degree measure and radian measure. Going further, dividing by 2, we can write 180 degrees is equal to pi radian. 180 degrees are equivalent to pi radians. Pi radians, when we say, we should know pi is 3.14 only. Never say please pi is equal to 180. That is wrong. Pi is 3.14 itself. So 3.14 radians are equivalent to 180 degrees. What do we mean? Go here. From here to here is 180 degree. That everyone knows. This is what 180 degree. 180 degrees. In this 180 degrees, how many radians could we cover? Look. 1, 2, 3 and little more. That little more is 0.14. So 3 and 0.114 makes it 3.14 radians. That is what covered in 180 degrees. It will be wrong to say pi is equal to 180. Just to clarify that, let us take another example to understand that. Here, One can say for example, this fork, the length of the fork is 10 centimeter. The same thing could be said like this also. Length of this fork is 2.5 inches. That means 10 centimeter is equal to 2.5 inches. But do we ever say therefore 10 is equal to 2.5? No. We do understand the meaning of 10 centimeters are equivalent to 2.5 inches. That doesn't mean that this 10 and 2.5 are equal. That is exactly what happens when we speak about the angles. 180 degrees are equivalent to pi radians. But we never say 180 and pi are equal. We never take pi is equal to 180. But pi radians are equal to 180 degrees. That is the correct statement. As we are introduced to a new measuring system for angle, and we have a connection between the degree measure and radian measure, that is 180 degrees equivalent to pi radians, let us learn how to convert degree measure into radian measure. Various angles we are going to consider: 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 120, 135, 160, 180, 210, 225, 240, 270, 300, 315, 330 and 360 degrees. Now, let's see. The first angle, the 0 degree. 0 degree is equal to 0 radian because there is no measure, 0. 0 degree equal to 0 radian. And 0 is being marked on the number line now. 0 is the real number measuring the angle 0 degree or 0 radian. Next, let's go by the relation that we already have derived. 180 degrees and pi radians are equivalent. 180 degrees equivalent to pi radian. 180 degrees we draw in standard position from here to here. And from here to here, if it is 180 degrees, hereafter we will be saying that this angle is pi radians. What is pi? Pi is 3.14. That means the radians, the number of radians from here to here is 3.14. As we already saw it in the previous section, one radian is so big, second radian, and there will be a third radian and 3.14 radian included in 180 degrees. Next angle. The double of 180 degree is equal to 360 degree. Double of 180. Therefore, in radian, double of pi is 2 pi. So 2 pi radians, and we plot 2 pi on the number line here. 2 pi radians. 2 pi is a real number whose value is 6.28 approximately 3.14 into 2. 6.28. So in one full rotation 360 degrees are there. 360 degrees will be equivalent to 6.28 radians. 6 full radians and little more. 6.28 radians. That is what we call 2 pi radians. Here it is. Next is here 90 degree. As we know, 90 degrees are just half of 180 degree. 180 degrees half. 180 degrees in radian, it is pi radian. So 90 degree will be its half, pi by 2. Pi by 2 radian. Pi by 2 radian and 90 degree equivalent. In standard position, it is starting from here until here. Starting from here until here. Anti-clockwise direction. 90 degrees, same as pi by 2 radian. One thing need to be noticed here. See, the small c that is written at the suffix position is not being used. Usually, no unit is written when the angle is measured in radian measure. That is conventionally taken so. So, in case the angle is written without a unit, unlike these degrees, small zeros put at the top, if there is nothing written, we take it for granted the angle is in radian measure. Now let's go further. Look, this angle from here to here. As we know, from here to here is 270 degrees. 270 degrees. So this 270 degrees are just at the middle of 180 and 360. So, in other words, we can say 270 degrees will be equivalent to 3 times 90. 1, 2, 3 90s. 3 times 90 is 270. So we can say 190 is equivalent to pi by 2 radian. So 3 times 90 degree will be equivalent to 3 pi by 2 radians. Here it goes. 3 pi by 2 radians. So 270 degrees are equivalent to 3 pi by 2 radians. Now this pi by 2 and 3 pi by 2. Pi by 2 came just exactly in the middle of 0 and pi. And 3 pi by 2 is in the middle of pi and 2 pi. Let's go further. This angle 45 degree is exactly half of 90 degree. 90 degree is equivalent to pi by 2 radians. Its half will be pi by 4 radians, 45 degrees. Pi by 4 radians. This is pi by 4 radians. Now, as this ray is making the first quadrant exactly into two halves, 145 and another 45. Same we can do in the other three quadrants also. Here they are. So, now we have got actually 8 partition. Each of them is a 45 degree. 1, 2, 3, 4, 5, 6, 7, 8 partition. 145, another 45, another 45, another 45, etc. Now let's see. This is 145 degree, that is 1 pi by 4. 2 pi by 4, 2 into pi by 4 is pi by 2. 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4 and 8 pi by 4 is again 2 pi. So, this new 4 angles we can say 1 pi by 4, 3 pi by 4, skipping this one, 5 pi by 4, 7 pi by 4, 1 pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. They are the angles 45 degree, 135 degree, here it is 135 degree. 225 degree, that is this one. 315 degrees here. Next is using another angle that is 60 degree. 60 is 1/3 of 180. 180 divided by 3 is 60. So 180 degrees, 1/3 is 60 degree. Pi radians, 1/3 will be radian measure here. Pi by 3. 1/3 pi by 3. So 60 degrees are equivalent to pi by 3 radians. Now, in the other three quadrants also, corresponding to this 60, we get 3 more angles. They are, this is 160, one more 60 makes it 120, one more 60, 3 times 60, 1, 2, 3, 60 is 180. 180 degree already we have written as pi. So we will go further. This is 4 times 60. 4 times 60 is 240. Then 5 times 60. 5 times 60 is 300. So these 4 angles will be as 60 degrees pi by 3. Here it is 2 pi by 3. It is 4 pi by 3. Skipping 3. 4 pi by 3 and 5 pi by 3. So we have angle 60 degree pi by 3. 120 degree is 2 pi by 3. Then 4 pi by 3 is 240 degree. 240 degree 4 pi by 3. And 300 degree is 5 pi by 3. And lastly, one more set, that is with the help of 30 degrees. Look, 30 degrees is 1/6 of 180 degrees. 6 times 30, 180. So this degree measure 30 degree can be written as pi by 6 radians, pi by 6. So 30 degree is pi by 6 radian. Let's see the other 3 angles we may get in the other quadrants. Here 150 degree, 210 degree and 330 degrees. What will they be? Look, this is 150 is 5 times 30. 5 threes are 15. So 150 degree will be 5 times pi by 6, 5 times pi by 6. And this is 7 times 30, 7 times pi by 6. This is 11 times 30. 330 is 11 times 30. So 11 times pi by 6. And we have the set of angles pi by 6, 5 pi by 6, 7 pi by 6 and 11 pi by 6. Pi by 6, 5 pi by 6, 7 pi by 6 and 11 pi by 6. All these angles in radian measure we need to remember. These standard angles at least. The most frequently used angles at least. All these degree measures we should be able to speak in terms of radians also. Now, this is just a shortcut to remember. But there is formal unitary method to convert also. In case we want to convert any other angle, we can go by unitary method. That is 180 degrees equal to pi radian. 1 degree equal to pi upon 180 radian. Therefore, any degree, theta degree is equal to pi upon 180 into theta radian. That is also possible. That we will learn next. We will now see how we could calculate the radian measure, how the conversion can be done using unitary method. 180 degrees equal to pi radian. This is the conversion relation that we have to keep in mind. When we want to convert degree measure into radian measure, take the equation 180 degree equal to pi radian and 1 degree is equal to pi upon 180 radian. If 1 degree is equal to this much, what about 60 degree? That will be pi upon 180 into 60 radian. This we simplify. 60 and 180, common factor 60. So we are left with pi by 3 radian. See here, 60 degrees equal to pi by 3 radian. This is how we do the calculation using unitary method. Now, in case we want to convert it back, convert radian measure into degree measure. Take the relation pi radian equal to 180 degrees. Again go by unitary method. 1 radian is equal to 180 upon pi degrees. Therefore, pi by 3 radian if we want to calculate, that will be equal to 180 by pi into pi by 3. For 1 radian, this many degrees. For pi by 3 radian, this many degrees into pi by 3 degrees. Simplify it. This is 180 by 3, that is 60 is left now, which is equal to 60 degree. So, this 60 degree we converted into radian and pi by 3 radian we converted into 60 degree. Using this rule, we can go on converting any other angle also. This is called unitary method. Let's do some examples. Find the radian measure corresponding to the following degree measures. 25 degree. The conversion equation we have to keep in mind is 180 degrees equal to pi radians. We'll go by unitary method. 180 degree equal to pi radian, therefore 1 degree is equal to pi upon 180 radian. Therefore 25 degrees equal to pi upon 180 into 25 radian. Calculated. It comes to be 5 pi by 36 radians. That's all. Unitary method. Next example. 1 minute is 1/60th of degree. This is subdivision of degree measure. It is degree measure itself, subdivision. There are 60 minutes in 1 degree. And this is what the minutes symbol. So 1 degree is 1/60th of 1 minute is 1/60th of a degree. So what will be 30 degree? Minus 47 degree 30 minutes can be written as minus of 47 degree plus 30 minutes. 47 degree keep as it is. Convert this 30 minutes into degree. Only then we can convert it into radian measure. So 30 minutes will be 30 into 1 upon 60 degree, because 1 minute is 1/60th of degree. So 30 minutes is 30 into 160 or 1 by 60 of degree. This is half degree. So we have what the angle is minus 47 degree plus 0.5 degree. So why don't we put these two together? Now both are degrees. That is minus 47.5 degree. So far we have not converted it into radian. It is only changed into degree measure itself from minutes. Minutes is actually fraction of degree measure. So now that fraction is expressed together, both full angle and fraction angle, 47.5 degrees. Now we go by converting. Minus of, we are going to convert into radian measure. To convert into radian measure, this is what the unitary method tells us. 1 degree is pi by 180 radian. So any other degree is pi by 180 into that angle. So 47.5 into pi by 180. This need to be simplified little bit. Yes, this is what we are getting. 19 by 72 pi. This many radians. Next example. Find the radian measure corresponding to the following degree measures. You may use value of pi as approximately 22 by 7. First part, 11 by 16 radian. As we know, when there is no unit mentioned in the angles, it must be radian measure. So we want to convert this 11 by 16 radians into degree measure. The conversion goes this way. Pi radians are equivalent to 180 degrees. This is the conversion equation we should use. So 1 radian must be equal to 180 by pi degrees. Unitary method we are applying. Pi radians 180 degree, 1 radian 180 by pi degree. So 11 by 16 radian will be 180 by pi into 11 by 16 degrees. 180 by pi multiplied by 11 by 16. These many degrees. Let's simplify it further. The value of pi, we are expected to use this. So put 22 by 7 there. And let's go simplifying it. These many degrees are there. Go ahead. That is, we can cancel 22 and 7, 11. Then 7 is multiplied in the numerator. It turns out to be 315 by 8 degrees. That is 315 if you divide by 18. 3 times in 31, 8 3s are 24. Subtract 7 and 5 carry it forward. 75, 8, 9 times. 9 8s are 72, 3 balance. So we have 39 full integer and 3 balance. So we write it like this. 39 plus 3 by 8. This much degrees. This fraction is converted into this. So we can write it as 39 degree plus 3 by 8 degree. 3 by 8 degree is a fraction of a degree. Fraction of a degree is measured in minutes. So to get the minutes value, 3 by 8 degrees, it's not even 1 degree. 3 by 8 is less than 1. 3 by 8 degree means 3 by 8 into 60 minutes. What is this? 3 by 8 into 60. Let's calculate and see. 180 by 8, we get 22. So we have 39 degree already and 22 minutes. Still there is balance. 4 is balance. 4 by 8. So 4 by 8 minutes. Now going to be converted into 4 by 8 into 60. This many seconds. Next subdivision of degree. 60 seconds are 1 minute. 60 minutes are 1 degree. So this we need to simplify now. That is coming 39 degree, 22 minutes, and what is this fraction minute? That goes into seconds. So 4 by 8 is half, half into 60 is 30 minutes. So this angle given in radian measure is nothing but 39 degree, 22 minutes and 30 seconds. We usually write it like this instead of showing the addition. We write it like this: 39 degree full, 22 minutes full, then the balance angle is 30 seconds. Next, minus for radian. Minus for radian is equal to minus of 4 into 180 by pi radian. 180 by pi. This is the multiplication factor. Using this unitary method, we have already developed it. So 4 radian will be 4 into 180 by pi degrees. Let's simplify it further. Using the value of pi, 22 by 7. 22 by 7 in the denominator, 7 is multiplied in the numerator because of reciprocal. Then 180 into 7 upon 22 into 4. Simplifying further, we reach at 2520 upon 11 degrees. Now this division, let's perform and write it as an integer part and remaining fraction part. If you do the division, 229 times 11, then 1 is the remainder. So 1 upon 11 will be the balance. It means there are 229 degrees full, complete, and 1 upon 11 degree also. This 1 upon 11 degree we can now convert into minutes since it is a fraction of a degree. So 1 upon 11 into 60 minutes, which means 60 upon 11 minutes. Again, 60 upon 11 also you divide and separate it into integer and the remaining part. 60 upon 11, 5 times 11, 55, and there is again 5 left. So the fraction part will be 5 upon 11. And that 5 upon 11 is a fraction minutes. To convert into seconds, multiply by 60. That is 6 5s are 30, so 300 in the numerator upon 11. 300 upon 11 minutes. Do the division. 27 minutes and there is little further balance. That part we will ignore. So we conclude 229 degree, 5 minutes, 27 seconds is the angle, minus 4 radian. Remember, this minus sign is being maintained till the end. So angle is already minus, negative angle that you maintain. Only the numerical part is being calculated like this.